and very good evening to all of you. I hope you have had a very good day today. Uh, in this video, I'm going to introduce producer theory. In the previous videos, that is in video number 434 up to 440, 460, we have discussed consumer theory in greater detail. And in this series of lectures starting from 461, I'm going to discuss producer theory. So this is an introductory video lecture, and this will be followed by other lectures in which I will give a complete detail of the producer theory. So watch this video up to the end, and hopefully you will understand the whole idea. We know that consumption and production are the two most important activities in the ordinary business of man's life. The economic activity not only involves consumption but also production and trade. While the theory of consumer behavior, as I mentioned, was discussed in greater detail in videos from 434 up to 460, this video and the coming videos will be based on the discussion of a producer theory. So this is the second important actor in economics, which is known as firm, and this is also known as producer. So I will be discussing the behavior of the producer or the firm. Firm is an entity which combines various inputs and it processes those inputs and transforms into output. So production is the process of transforming inputs into outputs. A firm or a producer carries out the production process by transforming inputs into outputs, and to do that the firm implies a certain technology. So what is that certain technology? I'll discuss that. Typically, inputs which are used in the production process consist of labor, capital equipment, raw materials, and intermediate goods, uh, which may be purchased from other firms. On the other hand, outputs consist of finished products or services or intermediate goods produced by a firm to be sold to other firms. So a firm produces outputs from various combination of inputs. In order to study firm choices, we need a convenient way to summarize the production possibilities of the firm. That is, which combinations of inputs and outputs are technologically feasible. If the firm produces a single product from many inputs, its technology can be represented by a production function, where production function is a physical relationship between inputs and output. So think of a production function f, which is mapped from the domain, that is non-negative n-dimensional Euclidean space, into R, which is positive, that is a real valued function, and it describes for each vector of inputs x, which consists of x1, x2 up to xn, the amount of output q as a function of f of x that can be produced. For any fixed level of output q bar, the set of inputs vectors producing q bar level of output, the set of x, which is in the non-negative rthant, that is positive rthant, non-negative rthant, or n-dimensional Euclidean space, such that the function f of x is equal to q bar and is called the q level of isoquant. And n isoquant is a level set of the function, or it is a curve which shows various combination of two inputs which are capable of producing a given level of output. When the production function f is differentiable, then its partial derivative, that is curly f of x divided by curly xi, is called the marginal product of input I, and that is abbreviated as MPI, marginal product of input I. The marginal product of input I, which is denoted by MPI x, indicates the rate at which output changes per additional unit of output I implied. That is, it means marginal product of input I means change in the total product due to a unit change in the quantity of input I. The MPI is a measure of returns to variable proportions, that is, of how output varies as the proportions in which inputs are used change. On the other hand, there is another concept that is known as returns to scale, which measures how output responds when all inputs are varied in the same proportion, that is, when the entire scale of operation is increased or decreased proportionally. So I'll discuss both of them, the variable proportion, returns to variable proportions, and returns to scale in the coming slide. And here in this figure we can see, I can discuss both. Returns to variable proportion, which concerns how output changes along x2 bar, keeping x2 constant and varying x1. It means if we keep the amount of x2 unit constant and we increase the amount of x1, then the output will vary along this horizontal line. And that is why we call it returns to variable proportion, because we keep one input constant and we vary or we change the amount of the other input. So that is why we call it returns to variable proportion. On the other hand, return to scale concerns how output increases or changes along this OA line, varying both inputs x1 and x2 at the same time, and we maintain a constant proportion of the two inputs, that is x2 divided by x1 is equal to alpha. So here we keep the proportion of the two inputs constant, but we increase both inputs, and the outputs increase along this ray OA. This is array, and you can say this is kind of a 45-degree line. So a production function f mapped from the domain non-negative orthant or n-dimensional non-positive n-dimensional Euclidean space into codomain, that is R plus, that is a real number which is positive, and it has a number of properties. And the first property is that there will be constant return to scale if for all t greater than 0 and the vector input in the Euclidean n-dimensional positive Euclidean space, and f of tx is equal to tf of x. That is, if we increase all the inputs by some amount which is positive and that is equal to t, and then if we can factor out t completely, then there will be constant returns to scale. And it basically means that if the ratio of change in the input is equal to the ratio of output, change in the output, then we have constant returns to scale. Then we have increasing return to scales if for all t greater than 1 and x is in the n-dimensional positive Euclidean space and f of tx is greater than tf of x. On the other hand, there will be decreasing return to scale if for all positive t greater than 1 and the input vector x is in the positive Euclidean space, n-dimensional Euclidean space, then f of tx is less than tf of x. If the production function is homogeneous, return to scale can be associated with the degree of homogeneity. If the production function is homogeneous of degree k greater than 1, it must exhibit increasing return to scale. If k is less than 1, then there will be decreasing return to scale. The converse may not hold true. If the production function is homogeneous of degree k is equal to 1, it has constant return to scale, and vice versa. Remember that a production function f mapped from the domain, which is a positive n-dimensional Euclidean space, into positive R, that is a real valued function, is homogeneous of degree k if for r lambda greater than 0 and input vector x in the positive n-dimensional Euclidean space, f of lambda x is equal to lambda raised to the power k f of x. For example, if f of x1, x2 is equal to x1 raised to the power alpha, x2 to the power beta is homogeneous of degree k, and that is equal to alpha plus beta. That is, alpha plus beta is the degree of homogeneity. The rate at which one input can be substituted for another input without changing the amount of output is called the marginal rate of technical substitution. So marginal rate of technical substitution is the rate at which one input is substituted for another without changing the output, that is along the same isoquant or production indifference curve. And this is the same like marginal rate of substitution in the consumer theory, but in producer theory its parallel is marginal rate of technical substitution. And production function, what is production function? The firm's production function for a particular good Q, where Q is a function of K and L, where K is the amount of capital and L is the amount of labor, and it shows the maximum amount of output that can be produced using various combinations of capital and labor inputs. In order to produce outputs, we need inputs, and these inputs can be combined only in certain ways in order to produce outputs. The set of constraints defining how one can combine or convert inputs into outputs is called a technology or technology of the firm. Hence, the right way to view a technology is as a constraint on the process of production. In other words, a production function summarizes a technology a producer faces in the economy by describing the technology as a constraint on the producer's ability to produce. We can depict the production function by a set of isoquants or production indifference curves or an isoquant map, with each isoquant defining various combinations of the two inputs that are required to produce a given level of output. Suppose the firm has L possible goods to serve as inputs and are outputs. If a firm uses yji units of the good j as an input and produces yj o of the good as an output, then the net output of good j is given by the equation yj is equal to yjo minus yji, where the superscript o and I stands for output and input respectively. We assume that a good can be used as an input or as an output, and that is why the net output of the good j is given by the equation yj, which is equal to the production of yj as output minus yji, which is in which this yj is used as input to produce yj output. There is a concept of the production plan, which is simply a list of the net outputs of various goods, and we can represent a production plan by a vector y in L-dimensional Euclidean space, where yj is negative if the jth good serves as net input, and It is positive if the jth good serves as a net output, as I mentioned earlier. And the set of all technologically feasible production plan is called the firm's production possibility set. So, my dear students, you must remember both. One is production plan and one is production possibility set. The production plan is simply a list of net outputs of goods, of various goods, where the set of all technologically feasible production plans is called the firm's production possibility set, and that is denoted by Y as a subset of L-dimensional Euclidean space. The set Y is supposed to describe all patterns of inputs and outputs that are technologically feasible. It gives a complete description of the technological possibility facing the firm. So, ladies and gentlemen, this is a brief introduction to the theory of producer. This video will be followed by other videos which will discuss the producer behavior. Thank you very much for watching this video. If you haven't yet subscribed to this channel, kindly subscribe to the channel and don't forget to click on the bell icon so that you can get timely or regular notifications about my videos that will be uploaded for you in the near future. Thanks for watching. Kindly subscribe various videos of this channel in various WhatsApp groups and social media so that this could reach to the maximum possible number of people. Thank you and